Hi guys, it's me UB Programmer and welcome to the Pytorch series, and the topic we will discuss today is matrix multiplication. So let's get started with the lecture of matrix multiplication. So here are the notes. Short for matrix multiplication is a process of multiplying two tensors, and we already know that tensors are representation of vectors and matrices in the Pytorch, right? And but the main thing about this matrix multiplication is this condition: the number of columns of first tensor must equal to the number of rows of second tensor. And why we are using this matrix multiplication? Let's see that. Because we want to uh, use the shortcut to do the operation of this multiplication and then sum. So here you can see we are doing the two operations. One is the vector of input multiplied by the vector of weights, and then combining them into a value, right, finding their sum. But this is exactly the matrix multiplication, and we can just do that with the help of this function torch.mm, and then you pass your parameters, right? Just like that. So let's see in the coding and the practical of it, right? As you recall, in the lecture 1 you have the features, weights and bias, and you got your result as an output 0.1595, right? Now we have the exact same similar setup in the lecture 2. We are importing the torch. We have our sigmoid activation. It is really a simple function, right? Then we got our features, weights and bias. Now if I just for you if I just print the shape of this features and weights, let me just again run it, because I have already run it, so it should give only 5, right? Because it is a single row vector, right? So it is giving me only 5. And then if I just print the shape of this weights vector, it is also 5. But we want to use the matrix multiplication, and the condition is number of columns of first tensor is equal to the number of rows of second tensor. But the requirement here is not being satisfied, right? So what we will do is, using this view function, we will reshape our features and weights. So first we will convert it into a 1 by 5. So that means we have one row and 5 columns, just like that. So it has 5 columns and one row, right? You can clearly see that. And if we print their shapes, we got 1 by 5 and 1 by 5, same for the uh, both vectors. But now we can use our logic and do this 1 by 5 multiplied by 5 by 1. So let me just grab a pen and clear this out, right? So if you have a vector like this, let's say, so this is 1 value, 2 value, 3 value, 4 value and 5 value. So there are 5 values in one rows, in the one row, right? 5 columns. And if you want to multiply it another vector, then you have to arrange a vector like this. The second vector should be like this: 1 2 3 4 5. So this is the setup we want in our shapes, right? So what we will do is, we will just reshape our weights, the second tensor, into 5 by 1, and you can see the size of it or shape of it, right? And then we can just easily say torch.mm, short for matrix multiplication. Then we pass our features vector and the reshaped weight vector, right? And obviously adding the bias term. And you can see that we are getting the same result, 0.1595 and 0.1595. So but here we was doing this multiplication and this addition, two separate operation manually, but here it is being done by the matrix multiplication. So that was it for the lecture, and we will come to the sequential layers and a lot of other stuff later, but for now we have to build a base on which we can stand, right? So that was it for the lecture. I will meet you in the next one. Thanks for watching.